Welcome again, ladies and gents, to another flipped lesson. Today, our focus is on understanding how to use this equation, Q equals mst. Now we know Q means heat. So our whole focus for this lesson is to understand how we can calculate a number for heat. If we think about an example from our endothermic and exothermic day, we had this box of water here. Don't write any of this down, this is just a quick review. We learned that if I have a high temperature, it means my particles have a high kinetic energy. If I have a low temperature, it means my particles have a low kinetic energy. If I put these two objects next to each other, heat is going to transfer from the hot object to the cold object until they reach their average temperature, which is in this case 50 degrees Celsius. So we were able to calculate that your hot water drops its temperature by 40 degrees Celsius, and that your cold water increases its temperature by 40 degrees Celsius. But we weren't really able to figure out how much heat is moving. How much heat is the hot water losing in order to drop its temperature 40 degrees? And how much heat is the water gaining to increase its temperature 40 degrees? That's what we're going to learn to do today. Is when we have heat being transferred, we can calculate an actual number to figure out how much heat is being lost or how much heat is being gained. But first, we have to understand the units that we use to measure heat. So the first unit we use is something called a calorie, which you guys are very familiar with. Here's the fancy science definition. A calorie is the amount of energy needed to raise the temperature of 1 gram of water 1 degree Celsius. So what that means is that if I had a hot plate and I had a beaker in it that had water, but it was only 1 gram of water, the amount of energy I need to take this temperature up by 1 degree Celsius is going to equal 1 calorie. So if this was at 32 degrees Celsius to start, I would have to put 1 calorie in to get it to 33 degrees Celsius. Now this chemistry calorie with a little c is a little bit different than the food calorie you guys see on the food labels that you eat. A food calorie is written with a big capital C because a food calorie is actually 1,000 of these little chemistry calories. So if you see a lowercase c, it means chemistry calorie. If you see a capital C, it means food calorie. So here, this whole milk has 150 food calories. That means it would equal 150,000 of our chemistry calories. That could raise a lot of water, a lot of degrees Celsius. Now the other unit that's commonly used is something called the joule. This is the SI unit, and you'll actually see in some countries around the world, they'll label their food with joules instead of calories. How we go between joules and calories is by using this conversion factor right here. So 1 calorie is going to have the same amount of heat in it as 4.184 joules. You do not need to memorize this. I will give this to you anytime you need it. So these are the two units that we use to measure heat transfer. So let's practice converting between these guys here. So we know that 1 chemistry calorie is equal to 4.184 joules. So let's say, for example, I measure that I transfer 60 calories of heat. But I don't want to know how many calories it is, I want to know how many joules it is. I can set up a conversion factor. So how many joules are equal to 60.1 calories? And all I'm going to do is track my units. I'm going to use this conversion factor here. So since calories are on top, I have to put calories on the bottom. That means my 4.184 joules is going to go on top, and I'm just going to multiply them because my calories cancel and I want to get to joules. So 60.1 has 3 sig figs, so when I multiply these two things together in my calculator, I'm going to round the answer to 3 sig figs, which would get me to 251 joules. The second example, we don't want to know how many little calories there are, we want to know how many big capital chemistry calories there are in 28.4 joules. So we're going to go ahead and we're going to set up a similar conversion problem. So I want to know how many big food calories are equal to 28.4 joules. This time, since I'm starting with joules have to go on the bottom, so my 4.184 joules goes on the bottom, and my one small chemistry calorie goes on top. My joules cancel and I'm in chemistry calories, but I don't want chemistry calories for this one, I want food calories. So we learned on the last slide that 1,000 of my little chemistry calories is the same as one big food calorie. I want you guys to practice typing this into your calculator. So you do 28.4 divided by this number. If you do it correctly, you should get this number here, 00679. Go ahead and hit pause and try that now. And when you're done, come on back to the video. So now that we've talked about the units we measure energy in, what happens if we don't have water? Because both joules and calories are based off of how much energy it needs to raise water. What if we don't have water? There's a whole bunch of different stuff in this world we can heat up. So what chemists did is they did a little bit of experimenting. They put a whole bunch of different materials onto hot plates, and they figured out how much energy you needed to take that substance 1 degree Celsius hotter than it was. Instead of calling it a calorie or a joule, what they did is they changed that definition to specific heat. So the specific heat capacity of a substance is for any substance. It tells us that it's the amount of energy required to change the temperature of 1 gram of any substance by 1 degree Celsius. So specific heat can be used for anything, not just water. But if you look at the definition, this is very, very close to a calorie. The only word that's changed here is this word substance. So the specific heat for any substance is how much energy we need to take 1 gram of it 1 degree Celsius hotter. We call it specific heat for short, and the units that it's usually measured in are joules over gram degree Celsius. So what does specific heat tell us? If I have substances, they're going to respond to being heated differently. For example, if I have a hot plate, and on that hot plate I have 1 gram of water, and I have 1 gram of gold. If I put 4.184 joules of energy into these substances, my water is going to increase by 1 degree Celsius, but my gold is going to increase by 32 degrees Celsius. That's insane. 4.184 joules can only raise water 1 degree Celsius higher, but the same amount of heat can take gold 32 degrees Celsius higher. What the heck is going on? It's all about this specific heat. It's all about how much energy we need to change the temperature. And one thing I want to bring you guys back to is the idea of the beach in the summer. When you guys go to the beach, the water feels nice and cool, but the sand feels really, really hot. Both these things are being heated by the sun all day, but because the water needs more energy to heat up than the sand, the water's temperature is not going to heat up as much, while the sand is going to get really, 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 really hot. It's because water needs 4.184 joules to increase its temperature, where sand only needs 0.19 joules to increase its temperature. So because this takes way less energy to heat up, as the sun beats down on it all day, the sand is going to get significantly hotter than the water. So specific heat just helps us understand that not all substances respond to heat the same way. Some heat up really, really slow, while others heat up really, really fast. So with that, we can go ahead and we can do some calculations. And the calculations are all based off this equation, Q equals ms delta T. What do all these letters mean? Q we know means heat. And the unit that it will be in is either going to be joules or small chemistry calories. M is mass. It always has to be in grams. S is your specific heat, and that's going to be in joules per gram degree Celsius, and your delta T is going to be your temperature change. That's going to be in degrees Celsius, and how you calculate your temperature change is you take the temperature of your final substance and you subtract the temperature that it started at. And that is really important, that you calculate temperature change this way every single time, no matter what. So if we want to figure out how much heat is being transferred in an endothermic or exothermic process, we have to know how much of the substance that we're using, the specific heat of that substance, and the temperature change the substance undergoes. So for example, if we look at this problem here, we have a 5.63 gram sample of a solid gold is heated from 21 to 32 degrees Celsius. How much energy is needed to do that in joules? And we know the specific heat of gold is 0.13 joules per gram degree Celsius, because I can just go ahead and look it up in a book. So as we look at this equation, this is my mass, this is my delta T, this is my S, so I'm solving for Q. So we just put the variables in, and we plug and chug. So Q equals 5.63 grams times 0.13 joules per gram degree Celsius times 32 minus 21. So I'm just going to calculate that in my calculator. I'm just going to do 5.63 times 0.13 times my temperature change, which is 11 degrees Celsius. I'm going to round to 2 sig figs, because this has 3 sig figs, this has 2 sig figs, and this has 2 sig figs. So my Q would equal 8.1 joules. And I know that my unit is joules because the heat unit in my specific heat number is joules. So what this tells me is that in order to take my 5.63 grams of water 11 degrees Celsius higher, I need to put in 8.1 joules of energy. Now we don't always need to solve for Q in these equations, we can solve for any variable. So what I'd like you guys to do right now is I'd like you to try this one and answer the question that goes along in the Google form. So a 1.6 gram sample of a metal that has the appearance of gold requires 5.8 joules of energy to change its temperature from 23 to 41. Is the metal pure gold? I want to use this equation plus the information in the problem to figure out, is this substance actually gold? And put your answer in your Google form and tell me why. And we'll start class tomorrow by going over this example. Remember, if you have any questions, you can always email me or swing by school before help. Have a great day, guys.